Hey everyone, I'm really excited about this one. We're going to build a multimodal vector store image search engine. Let's see how it works. Let's search for shirts. There we go. Let's search for jeans, hats again, scarves. There we go. Our database is only 500 items long, so we do get some unrelated items because we are doing cosine similarity and returning the top 10 most related items. We can also run it internal and just search for hats. And here we go. We are now returning 3 items. These descriptions were generated by GPT Vision using these images. And these images are so tiny and it was able to describe them really well. And we did this with a very short prompt and we didn't use any JSON mode or anything. So this is very cool. Let's get started. And we are doing all of this with SQLite. And actually, this all started with me trying to do something like this. And I was looking at Docker, right? Which is a multimodal database, and I asked GPT about it, and it only knew about the earlier versions. Docker is at 0.4, so I just asked, can we store images in SQLite? And yes, we can with using blob objects. So I guess the important part is that we are using SQLite. So we begin with this database, which is products.parquet, which I've downloaded from Hugging Face. This was the database, fashion product images small. This is what it looks like. We're only using the images. We're not using any other additional information. So these images are very small, just this small exactly. So I've downloaded this and then I wanted to convert it to a SQLite file. So that's what we did here. We have a function. So these files are numbered 1 through 5, and all the files will be available at Patreon. Link will be in the description. So in the first file, convert to SQLite, we have a function that reads the Parquet file. And then we connect to a database using SQLite 3 connect. And then we create a table, okay, with just an ID and a blob for the image. And then we have insert image, which we're going to insert the ID and the image into the data frame database. And then we set the name here, set the Parquet file here, and then we read it, connect to the database, create the table, and then we go over and we only pick the first 500 and then create the file. This original database actually has 44,000 rows. I mean, if you wanted, you could have used all of it, but I just decided to just pick the first 500. So when we do that, if we view this database with the SQLite Viewer extension, this one right here, when we view it with this, then we'll see, yeah, currently my cursor is having some issues, but we can actually use this DB browser. If you search for DB browser for SQLite, it's a nice, neat little program. I'm going to open the images DB so we can see what it looks like. There we go. So we have an ID and we have an image which consists of a blob, and you can see the images here, just like that. So this is a SQLite database with images in it, essentially. There you go. So that's it. So now we've converted our Parquet, grabbed the first 500 images and created a SQLite database. And next we're going to get descriptions for these images, because if we want to do similarity search and we need to get the embeddings for these images. And one way to do that is to call GPT Vision and get a detailed description of it, and then actually embed those descriptions next to the images. And then now the images are actually related with those descriptions and the associated embeddings. So it's like this. We have an image ID, or we have an image, and then we have its description is in JSON, and then we're going to get its embeddings and then put them into our database row by row. So when we ask a question, or like say like shirts or something, then we're going to do similarity search over this and return the most similar top K elements, however many you like. Okay, so to do this, we initialize our OpenAI, and we do want to set some retry wait time. This is in seconds, and then we're going to use async IO to get all 500 description for all 500 images simultaneously. So we're just setting these here because you might want to test it first with like 10 or 50 or something. And then max retries. So if you run into rate limit errors or something, we're gonna retry 5 times, each time waiting 10 seconds. Feel free to modify these. We have a function to connect to our database, and then a function to fetch all the images. And then we do have to check. So this was causing an error. So GPT-4 Vision, it only handles PNG, JPEG, GIF, and WebP formats. So this with the image and the IO bytes handles actually checking if the images in the database is one of those formats. If not, it skips it or it returns false, so we can skip it. All these code files will be available at Patreon. I have over 200 plus posts here. If you become a patron, I do appreciate your support. Feel free to check out some of the projects. I also have collections which you can browse easily. For example, exclusive videos for patrons. I'm going to try to make more of these, but I have many videos on, for example, fine-tuning and function calling, and you'll have access to all these files. Also, if you look at some of my higher tiers, you'll see that I have an availability at the AI Prodigy level. This comes with 3 hours every month, one-on-one meetings. If you're interested, take a look at that. And we create a new DB, connect to it. And this time we have an ID, the image, and we're going to create a description text. We're going to create a new DB. So images DB was our original database. We're going to create images with descriptions DB, right? And encode image is going to actually encode this image in a base 64. This is how we are sending the images to GPT Vision. So this is going to be for attempt in range of max tries, which we have set here. We're going to print descriptive information, and we're going to try to call GPT for Vision. If you're a helpful image descriptor, please respond with a JSON object returning every possible description of the image. That's it. So then we say describe the image with all possible descriptions and send the image. And I just set the max tokens to 1000. Get the description. If our attempt fails, then we'll sleep for the retry wait time amount and then try again. And then we have a function insert image with description, which will actually insert the description into our database. Then in the main, we just connect to the database, fetch the images, and then create a new database. Okay, and then we are going to use async. That's why some of these functions are defined with async, and we are using, by the way, async OpenAI to be able to work with async IO. And then we just loop over max concurrent images. So here you can actually, so we're going to loop over the entire images that is in this database one way or another, but max concurrent images decides how many do we want to handle at once. So whatever you set here, right up here, whether it's 5 or 500 is going to determine how many concurrent calls we make. You can also test it out. You can set maybe like 100. So you will get the first 100 images. So keep that in mind. Like I said, these code files will be available at Patreon. So if you wanted to play around with it, you can download it there, but we're going to review it here anyway. And now we get a batch, assign tasks, which we're going to send to run with asyncio.gather, which is going to gather all the descriptions, which is going to keep them all in order. And then we're going to just loop over them and then get the image ID and descriptions. And then we're going to insert image with descriptions. We're going to use this function, which we have defined above. And then we're just defining our original database and the new database. And that's it. So when we run this, we'll get all the image representation descriptions. So this is pretty costly, even though those images are very small. 500 images cost me $3-4. I made some mistakes, so it ended up costing me $10. Running it twice and plus some tests. Okay, now let's move on to the third file, which is getting of the embeddings. Again, we are going to get all the embeddings simultaneously using, again, async IO. I'm really getting used to async IO, and I like it. I also still like thread pool executor, if you see my other videos, but that's good for maybe up to 100 calls simultaneously, especially if you have a decent computer, but async IO can handle, tens of thousands of calls at the same time. Yeah. As long as you don't run into rate limit errors. So here again, we are connecting to a DB and we fetch the descriptions this time. Let me just show you then. Once we get the new DB with descriptions, let's see what it looks like. Okay, so now we have an ID column and an images, as you can see right here, and we get a descriptions for each. So these are very cool. Like, let's look at this image. Let's look at this one. So some green top or something. This is explained as this is an image of a person posing for the photograph, female, long standing, natural expression. Let's see. Okay, this one doesn't really, maybe we should have actually prompted it to define the product more so. Let's see this one. What is this? Okay, I'm just trying to pick a product like one. Maybe this lipstick, and its description is lipstick, red, black with golden accents, a new unused lipstick. So this white isolated background is settings, potential use, cosmetic products, brand indicators. There are no visible brand indicators. And this was the image, as you can see. So it's very good. So this leads me to believe maybe when we were sending the description comments, we could have actually set to define describe the product itself and not the image in general. But you can modify it for your own use case. Anyway, so we're going to add an embedding column to our new data frame database, and then we're going to get the embeddings using text embeddings 3 large. So I am using the full size, right, 3000 dimensions of it all. And update embedding, update the database with embeddings. And then we're going to get the old connection and new connection. And we're going to create the new database by backing up, by using .backup of the old connection, because we want to create a new database. And then we add the column to it, the embeddings column, get the descriptions. And then we again create a task to get the embeddings, calling the embedding functions, and with async.io.gather, call those tasks. And once we have our embeddings, then we loop over them and we print some information, update the embeddings, close the connections, and here we give the DB names. Yeah, so that's it. So this will create our embeddings. We can also open that database and browse and see what it looks like with the embeddings. Okay, again, we have our image, and then we have our JSON description, and then we have our blob, which is the 3000 plus embeddings from OpenAI text embeddings large. So we were able to, one step at a time, create a multimodal database of 500 rows long. So next step is actually search. This is the cool and fun part. Before we continue, I'd just like to show you the new app I built. I call it Fast Python, because you just come here and you don't have to type anything. You just pick your level. Let's pick trendy. Now we get some suggestions to learn Python with, and then we can refresh topics. It'll show you new topics every time. Let's say web scraping, and then it'll actually show us some information on that. You want to learn about GUI development, you can do that. It's very cool. You can actually increase this number for longer responses. Here we go, more detail. So whenever you have 3 minutes, you just check it out. I'll put the link in the description, and also check out my auto streamer, which allows you to create content automatically and do live streams. If you visit this website, you can see a live stream that I did with it, and you can see a sample site that it built. So AutoStreamer was building this website while live streaming it, and you can actually use this website and actually learn some Python. I also call this Learn for Python Fast. It's deployed at Railway. I also show how to deploy it at the end of the live stream as well. Okay, continuing image search terminal. Let's run this again and see how it was working. So this one takes in a question, let's say jackets, and then it returns 3 responses. This is the first response with a score of 0.30. It's a polo shirt. The second one is a pair of black pants. And this is a t-shirt. Maybe we don't have any jackets in the database. Let's search for hats. And we see that this is an image of a cap. This is an image of a baseball cap, and this is an image of a white baseball cap with all its descriptions. So let's see how this works. So essentially, we again have the get embeddings function here, because we'll have to embed the question as well. And then we are loading the database. And this part was very confusing, but I got a lot of help from Cursor and ChatGPT. The reason was that we are storing this as a blob object, and you just have to kind of load it just right. But this code does it. And then we have the get similarity. We're using the cosine similarity from scikit-learn. So this is going to perform cosine similarity over the embeddings column. And it's going to sort the similarities and return the top 3. And then going to return the top chunks and top scores. And in main, we open our database, load it, and I would just print the shape of it. And while true, we take in a question. Then we get the embeddings for the question, again, using text embeddings 3 large. Print the shape. And then we get the similar chunks and the scores using the get similarity function. And then we just print them. That's it. And next up is the image search with HTML. So this is again the same. Get embeddings, load database, get similarity. However, here we generate HTML. So I did specify to use Tailwind. So this is going to generate some HTML content. And this function is going to take in top chunks. And it's going to, I believe in this one, we are using 10, top 10. In the previous terminal version, we used 3. It's going to populate this. See, it's going to keep adding these divs. You can actually specify the width and height. And it's just going to write it to an HTML file. And then here we are going to run the main loop. You take in a question, embed the question, get the top chunks, and then generate the HTML file. So when we run this is where we see the really awesome stuff happening. So we can ask it a question such as lipstick. Let's see if we find that lipstick. Yeah, see, I think this was what we were looking for. Let's look for red lipstick. And kind of got up higher. Are there any branches? Yeah, there's, I guess, one. So, but this is only 500, items long. So if you probably had more items, it'll be more accurate. Yeah, so this is it. I hope you enjoyed this. So this is the HTML file it generates. It's using the blob directly in it. There probably is a better way to do it. This is fine too. It's just very long. Requirements for this is OpenAI, NumPy, Pandas, Pillow, Scikit-learn. I hope I'm not forgetting anything. I'll put this, of course, in Patreon if you download it. And, I really enjoyed this project. And the thing that was really striking to me is that I used mostly ChatGPT and Cursor. I don't think I wrote a single line of code. And it just really amazes me how many tools we have at our disposal. The Cursor is a great IDE. You can have Copilot chat and Cursor chat on both sides. Anyway, so I want to make more videos on focusing on my method on how to, I think, talk to GPT. I think that's going to be the most important skill. Anyway, I hope you enjoyed this. Again, if you do decide to become a patron, I'd really appreciate it. And as an ending note, don't forget that you can find all my videos at my website, echohive.live. Just take a look at it. And if you're a patron, you can find the code download links here very easily. Just like that. And you can just download it. Thank you again, and I'll see you in the next video.